Hey guys, today we're going to be doing a lot of factoring review. This corresponds with section P5 in your book. So you always want to look for a GCF when you're factoring. So here, see what they're both divisible by. 10 and 4, both divisible by 2. X cubed and x squared, you can factor out an x squared. So we factored out that GCF, and then you see what you're left with. Divide by 2, we're left with 5x. Divide by 2x squared, we're left with minus 2. On the next one, so this one's a little bit weird, but you see how they're both divisible by x minus 7, so you can actually factor that out. And when you factor out an x minus 7, you factor out x minus 7, you're left with 2x plus. And again, when you factor out an x minus 7, you're left with 3. So it's a little bit weird, but that's how you're doing that one. You can also factor by grouping. A sign that you're factoring by grouping is when you wind up with 4 terms. Okay, you probably want to aim to group. We'll group those first 2 together, and we'll group those second 2 together. We'll pull out GCFs individually. So these are both divisible by x squared. We're going to factor that out. When you divide by x squared, you're left with x plus 5. These are both divisible by negative 2. When you divide by negative 2, you're left with x plus 5. And that's your goal. Notice they both have an x plus 5, and that's kind of what this one was aiming for, or getting you to see, was when you factor by grouping, you want that common, that greatest common factor. So in this case, they're both divisible by x plus 5. When you factor it out, you're left with an x squared minus 2. And that's not going to go any further. All right, moving on. And the reason I'm breezing so fast is because I'm hoping this is review. Here we want to factor this, so we want to multiply to get 40, and we want to add to get 13. So multiplies to 30, adds to 13, I got 8 and 5. X goes on top of both, and those don't simplify, so we're going to have x plus 8 and x plus 5 as our factors. And we've actually already done this stuff. Next one, we want multiplies to get negative 14, adds to get negative 5. So what multiplies to negative 14 and adds to 5? I've got 7 and 2. We want negative 14 and a negative 5. So, oops, negative 7. So negative 7 times 2 is negative 14. And negative 7 plus 2 is negative 5. What goes up top? X. Why is that disappearing? So we have an x minus 7 and an x plus 2. This is your AC method. Remember, A times C, so we want to multiply to get negative 42, and we want to add to get 19, still that middle number. So numbers that multiply to negative 42, and add to 19, let's do 21 times 2. We want one of them to be negative, but we want a positive 19. So 21 plus negative 2 is 19, and 21 times negative 2 is negative 42. Now here's where this is really going to become beneficial. Here you go, 6x is going up top on both. And that's what we've kind of been working towards. 6 and 21, we do want to simplify, both divisible by 3. So you got 7, and then up here you got 2x. 2 and 6, both divisible by 2, so here you got negative 1, and here you got 3x. And those are going to be your 2 factors. We got a 2x and a positive 7, and we have a 3x minus 1. All right, so consider it factored. All right, so here, it's intimidating because you see the xy here. But we're still going to try and factor with that AC method just to see if we can get some numbers to get to 13. And we'll deal with the x's and y's in a second. So let's do our AC. 4 times 3 is 12. We still want it to multiply to get 12. And we still want it to add to get negative 13. All right, so multiplies to 12. I've got 12 and 1. Adds to negative 13, I've got negative 12 and negative 1. And I'm still going to put that 3x up top. So these are both divisible by 3. I've got x. These are divisible by 3. I got -4. And I've got, oh, that's a 3x. I don't know why I crossed that out. That's still there, sorry. So here's where the y's kick in. We're going to have an x minus 4, right? I'm going to leave a little space there. And 3x minus 1 to make this happen. Now this y on the end, to get and that y in the middle, all I have to do is make that second one have a y in there. Now I normally wouldn't write 1y, I would just write y. So we're going to go ahead and write y. And then you kind of see where that happened, or what happened. So x times 3x got me 3x squared. X times -y gets me -xy. -4y times 3x gets me -12xy. So -1, -12 makes -13xy. And then -4y, y makes 4y squared. So it's a little bit different way of thinking about it, but you can still kind of use this generically. You just kind of have to alter that y in there. Your hint here was difference of squares. That's what DOS stands for, difference of squares. So again, difference is subtraction, and these are two perfect squares. So remember what you do. Square root of 36x squared is 6x. Square root of 25 is 5. One's plus, one's minus. Difference of squares. Now this is actually difference of squares too. This is a perfect square and this is a perfect square. So we're going to go ahead and start the same way. Right? Square root of this is 9x squared. Square root of this is 4. One's plus, one's minus. Now here's the catch. Here you're done, right? In example 7 we're done. These don't go any further. Here, 9x squared plus 4, there's nothing else we can do there. But in this next one, this is actually difference of squares again. So 9x squared minus 4 can actually be simplified further. Square root of 9x squared, square root of 4, one's a plus, one's a minus. Now we're finally factored all the way. Next one. On the next one, so there's two routes you can go here. If you wanted to use the AC method, you can. You're just going to wind up with really big numbers. So what I'm hoping is you see that these are perfect squares. These are perfect squares. So what happens is the square root of that is 4x. The square root of this is 7. And that's a minus. And if you actually multiply that by itself, what happens is you'll have, let me just show you real quick. So you'll have 16x squared, which is what we want. We'll have the plus 49, which is what we want. And that inside term, you'll have negative 28x, and negative 28x will make negative 56x. So that is a perfect square. It's just a little bit different way of looking at it. Next one. Notice they're all divisible by 3x. We're going to pull out that GCF first. So we're going to have x minus 10x. Ooh, not x. Just kidding. Minus 10. There we go. My bad. X squared minus 10x and divide by 3x plus 25. Now that we pulled out our GCF, this does factor further. So we're going to have 3x. And we're going to say what multiplies to 25 adds to negative 10. So I've got x minus 5 and x minus 5. They will write that as x minus 5 squared. So you have 3x minus 5 squared. And that would be your final answer. The next one. So this one, they kind of just slip another a in there, right? Like you're not going to notice it. Slip another variable in there. So my advice, I see subtraction. I'm going to try and get this to be difference of squares, right? Difference of two perfect squares. So let's go ahead. I know 36a squared is already a perfect square. Here we have x squared plus 20x plus 100. I'm just going to leave that minus 36a squared on the end. Now here, this actually becomes, multiplies to 100, 10 times 10, adds to 20, 10 plus 10. So this actually becomes x plus 10 squared. So now you have difference of two perfect squares. So I know it's a little bit different way of thinking about it, but it is still difference of squares. So you'll square root x plus 10, square root 6a, all right? One will be plus, and then again, square root x plus 10 and 6a, and one will be minus. That's an a. So again, very similar to the difference of squares example we did back here, right? 6x, and then 5, one's plus, one's minus. Except for it looks a little different. X plus 10, 6a, one's plus, one's minus. Cubes. So there is a formula, but I have a little jingle. Cube root, keep the sign, square, square, multiply, take the opposite. So it actually is the formula. So let's use the jingle. You ready? Cube root, keep the sign. So that's the beginning. And then square, x squared. 1 times 1 square, positive 1. And then multiply, 1 times x is 1x, take the opposite. And it's factored. So let's try it on a little bit harder one. Cube root, so the cube root of 125 is 5x. Cube root, the cube root of 8 is 2. Keep the sign. And then square, so 5x squared is 25x squared. Square negative 2 is positive 4. Multiply, 5x times negative 2 is negative 10x. Take the opposite, plus 10x. So cube root, keep the sign. Square, multiply, take the opposite. And it just kind of helps you, instead of memorizing formulas, it's just a different way to memorize it. But you can use the formula, you can use the jingle, whichever you prefer. And last but not least, we've got some fractional and negative exponents. So we're actually going to still try and get a GCF, and your GCF is going to look a little different. So here I'm going to use that x to the negative 1/2. So we've got x minus 1 to the negative 1/2. And what I'm going to do is I'm going to rewrite this side. So we have x minus 1, and we want 1/2, right? We want 1/2. But we can break that up. Let's see. If we want a negative 1/2, we'd have to add 1 to make it become a positive 1/2. So all I did, remember when you multiply, you add exponents. Negative 1/2 plus 1 does get me positive 1/2. And what I just created was, notice now my GCF, right? These are both divisible by x minus 1 to the negative 1/2. So I'm going to go ahead and factor that out. And when I factor it out, what am I left with? So when I factor this out, I'm left with x plus. And when I factor this out, I'm left with x minus 1. So let's simplify a little bit. X minus 1 to the negative 1/2. This is 1x and 1x. This is 2x. And your last step, remember, you never leave a negative exponent. We're going to go ahead and use that reciprocal or put it in the denominator. So we got 2x minus 1. And then in the bottom, we have x minus 1 now to the positive 1/2. All right, that's it. Bye, guys.